My father was an excellent amateur pianist. My son is a professional jazz cellist, and most of the members of my family, including myself, are playing a musical instrument. And music was a very strong motivation for me to move to the hearing field and also to move to the field of deafness.
Sounds are important to us throughout our lives. Our sense of hearing can both save us in dangerous situations and create bonds with other people. And listening to a piece of music can change our mood.
Without hearing, you are completely isolated from the other people. It has been said, I think, by Immanuel Kant that not seeing isolates you from things, but not hearing isolates people from people.
Hearing is the first sense to develop in a healthy fetus, and its sense of hearing is already well developed by the 6th month of pregnancy. But in some fetuses, something goes wrong with the process. Christine Petit, professor at the Pasteur Institut in Paris, has identified more than 20 genes that can explain why.
When I began working on hearing, we knew already quite a lot regarding the way the auditory sensory system works, including how the auditory sensory organ, the cochlea, detects and encodes sound. By contrast, we knew nothing regarding the molecular mechanism involved in sound processing. And this was due to the fact that for each cochlear cell type there are very few cells, and this made it impossible to decipher this molecular mechanism by using classical biochemical methods. So I decided to develop a genetic approach of hearing, that is to isolate the gene responsible for deafness, because these genes were predicted to encode key molecules for hearing.
Together with Karen Steele, Christine Petit won the Brain Prize in 2012 for their efforts to understand deafness at a molecular level and to make it less of a mystery.
Most of the children who are affected by profound deafness at birth are affected by hereditary forms of deafness. But during life, you have other forms of deafness, and most of people being deaf are deaf, let's say, as adults, become deaf during adulthood. And for these forms of deafness, and especially for the late onset form, which is called presbycusis, there are some genetic factors. The heredity is much more complex.
She has studied these genetics in the field in Africa and the Middle East, where she examined a number of families afflicted with hereditary deafness. Around 5% of the world's population suffer from hearing impairment or actual deafness, and the hope is that in time we'll be able to provide better diagnosis, advice and therapies.
First of all, at the present time, we have no treatment for deafness. We have only auditory prosthesis, hearing aids if you are just hearing impaired, and cochlear implant if you are profoundly deaf. And in the future, in our lab, we are very much concentrated trying to develop, let's say, new treatment and especially gene therapy, and I am pleased to say that we have already very promising results in the animal model, meaning at the preclinical stage, and now we are working closely with ENTs in order to transfer these results to patients.